Primary and secondary standard substances are reference materials used in analytical chemistry to calibrate instruments, validate methods, and ensure accurate measurements. Primary standard substance. A primary standard substance is a highly pure compound with a precisely known concentration or content. It is used as a reference material to directly determine the concentration of an analyte in a sample. Primary standards are typically used in titrations, where a known quantity of the primary standard is reacted with the analyte to determine its concentration. Primary standards should have the following characteristics. High purity. The primary standard should be of extremely high purity, typically exceeding 99.9%. Impurities can affect the accuracy of the analysis. Stability. The substance should be stable and not degrade over time or upon exposure to air, moisture, or light. Traceability. The primary standard should be traceable to a recognized standard reference material, such as those provided by national metrology institutes. Solubility. The substance should be easily soluble in the solvent used for the analysis. Specificity. The primary standard should react specifically with the analyte, ensuring accurate and precise results. Common examples of primary standard substances include potassium hydrogen phthalate, KHP, for acid-base titrations, sodium carbonate, Na2CO3, for acid-base and precipitation titrations, and potassium iodate, KO3, for iodometric titrations. Secondary standard substance. A secondary standard substance is a reference material that is used to standardize a solution or calibrate an instrument. Unlike primary standards, secondary standards do not possess the same level of purity or traceability but still have a known concentration. Secondary standards are typically used for routine calibrations and quality control purposes. They are often prepared by diluting a primary standard substance to a known concentration. Characteristics of secondary standard substances include known concentration. The concentration of the secondary standard substance is known but may not be as precisely determined as that of a primary standard. Relatively high purity. While not as pure as primary standards, secondary standards still have a high degree of purity, typically exceeding 95%. Stability. Secondary standards should be stable and not undergo significant degradation or decomposition over time. Availability. Secondary standards are commercially available and often come with a certificate of analysis specifying their concentration. Examples of secondary standard substances include sodium chloride, for the calibration of chloride ion selective electrodes, potassium dichromate, K2Cr2O7, for the calibration of UV-Vis spectrophotometers, and ferrous ammonium sulfate, FAS, for the standardization of solutions of reducing agents.